I'm going to ask my calculator to graph this, so I hit the word button graph, and it should graph it for me. You have something that looks just like that, more or less. You're good? Good? Nope, still take it. Okay, so your window's all messed up. So you're going to shift, fix my window, and you're going to say, I'd like to start at negative 10. And then like to and then like to end at 10. And then like to start at negative 10. And like to end at 10. And grab again, access. Oh, no, it should do that naturally. You pick the grid window. How you pick the grid window can happen. If it's good, got a pretty picture. Oof. Stopping here, I don't have a pretty picture over here. What happened? That's pretty good. So let's hit draw. Amount, argument, error. Okay, so it's clear. Let's look at our window first. No, that's pretty good. All right, so, oh my goodness, something is here. Why did they do that? Oh, first, here we are. Oh, sorry, guys. The student here has got a rather large problem. Okay, I want you to why. Okay, so. Calculator, so you're not stuck here all period looking at that. Figure out that mess. All right, folks. This has done the graphing for you. By the way, you do have graph paper. You can graph this from time to time yourself if you really want to. How do we get the answers mechanically that we are thus far look for? Couple of choices. One, look at the picture. You can approximate these pretty closely. It looks like it goes right through at 4. I might guess x equals 4. I might look at this, say x equals 1.2. Would that be a good choice?
Yeah.
Suppose we get 1.4. I'd mark that wrong, guys. So we got to do better than that. So what we're going to do on the TI and on the Casio, it works on both. The Casio, you look at the little window underneath. It gives you a choice. One of them's trace. Don't push any buttons after you push the trace button. I'm going to press the trace button right now. Hit the trace button. Now, if you don't know where your trace button is, it says trace right there, that big one I just pushed. In the Casio, it's one of the little options right underneath. What? And you trace. All right. Oh, it always gets. It's only so smart. I believe you still get it. Yes, it always gets. I'll explain that in a moment. Yeah, you've got a fun little function on here. And that would be not responsive for any rate that does that. Yeah, inequalities, excellent. Yeah, so right now it's graphing it. You just can't see it because it's in a shade of 0. Get somebody else to help. Look at somebody else's calculator, and I'll try to spend an hour under your calculator sometime when I got time to do so. Yes. Did you ask to make lines? Yeah. Once you turn that off, set up grid on. No, I don't want that on. I want that off. Thank you. On. What? 1, 2, 9, 3. That means you're not on it. Did you hit trace? Yeah. You need any buttons after that? You sure? Okay, you got the little bit stuff. Good luck. I'm gonna hit trace now. No, it's. Oh, you got 2 lines on here. You got 2 graphs. Go plot. And you plot. Turn that off. Trying to play a bunch. You don't know what they do. Leads to problems later on in life. You have a weird point in space? No, that's probably okay.
Let me see.
You might not have 0, 8, by the way. You might have any number of points. So here we go. The trace function. I mean, you know how a trace function works. Next year in calculus, you're going to be asked. Next year in calculus, you're going to be asked to figure out where certain points are floating in space. Only way to do that, to approximate it, is to play it with the trace buttons. It's one of the buttons they make you use. We're going to check see if you can use it. So once I've hit trace, if I hit an up or down arrow, I leave the trace. So don't go left, don't go up or down. Only go left and right. So since I want to find where the 0 is and approximate it, what am I going to do since I'm right here? I'm going to go left, and it's going to start following. No, it's not. What just happened there? No. It's going to start following. Now it's going to skip right past it. Darn it. But taking a look, now I know it's somewhere between 1.3 and 1.4 on my graph. You're going to have different values because every TI is different. CASIs are pretty consistent. But that would give me an answer somewhere between negative 1.3 and negative 1.4. Well, X is where it's crossing the y-axis, right? The y has got to be close to 0, right? So the point before it, I'm up. The point after it, I'm down. It's got to be between those 2 points, right? Same reason we did before. So use that function, use the trace function to estimate your zeros. You should get pretty close. So you got negative 1.3 and 1.4. So yes, they're probably 1.4. That's closer. You're tracing? Yep. You're in R theta. Why are you in R theta? You're in polar mode. Yeah, you are. You may have actually loaded a program. Does anybody play with your calculator? You got 3 or 4 programs on there.
I didn't do it.
Right?
I know it. Wait, but what did we do after we highlighted?
All right. Well, now I have 2 people over here. I'm trying to calculate. Good luck, everybody. I'll try to fix those when I can. All right. Eyes up here. Enrico, you with me?
Yep.
Okay. So what I did, I hit trace and I followed it. And I got to here, it's been somewhere between the x value of 1.3 and the x value of 1.5.
Yeah.
Somewhere between those two. I might guess negative 1.4 based on that alone. That's still not the best way to do it, but it would work. It also works when you're trying to find weird points like maximums. So coming this way, I would say it's somewhere between 1.3 and 1.5 again. Keep going. I might say it's somewhere between 3.8 and 4.0. Might get that one wrong, saying 3.9, correct? So that's not perfect, is it? Nor can a calculator be perfect. It's not going to pick the points you want. We can force you to get closer and closer to picking points you want, but we can't make it pick the points you want. How do we get closer and closer? There's another function on here called, well, it depends on which version of the calculator you have. Second function, calc on the TI. On mine it's called a root. On yours it might be called a 0. Now for the Casios, you're going to look down here. You're probably going to hit exit. You're going to hit go ahead and graph it again, and then down below. Okay, and so you're going to use second function gsolve, which is roughly the same place. You got the TI. All right, you got Casio. Second function gsolve. So go ahead and graph it. So if you have a TI, you need to go down to root, you need to hit enter. Now, your TI, because mine is really, really old, it's up there, your TI is going to say left bound and right bound. Nick, you with me at all?
Yeah.
Okay, you would say left bound, right bound. Mine says upper and lower. Yours says left, correct? So you're going to go using just like trace, left and right arrows. You're going to go just to the left of the point you're interested in. And then you're going to hit enter. Then you're going to go to the right of the point you're interested in. You're going to hit enter again. And then it's going to ask you to guess. The TI can make approximately 7.2 million calculations a second. The time it takes you to guess, it can already check every single one in between those two. So what we're going to do for guess is we're just going to enter again, say guess yourself. And there's the root. Now that's the TI. Okay? So I'm going to run through the TI instructions one more time because the Casio ones are stupid simple. Okay, get your thing graphed up ready. Okay? So here you go. Let's try it again. I want to find a 0. So I'm going to go second function, calc. I'm going to go down to root, or it could be 0 on your calculator. It says find the left bound. Again, mine says lower bound. So I'm going to drag it using the trace buttons, left and right only, not up and down, just left and right, till I get below it. Go to the left of it. To the left of it. Left bound, you have left bound? With me, Dulce? Yeah, I did the wrong bound. Okay, that'll really freak it out. Okay, so I go left bound, I hit enter, and then I move past it to the other side. I go right bound, enter, and then it says guess, because of the TI, it's too lazy to guess itself. Hit enter again, and it'll find it for you. Find all 3 of those points using that function while I tell the Casio people how much better their lives are. So here you go. If you have a Casio, you've got a graph. You ready to go? Now you hit second function F5, which is gsolve. That means graph solve. Second function gsolve. One of the choices is root. Hit that. Now just wait. I gave you the first one. You write that one down really fast. Then hit a right arrow and it'll give you the next one. Then hit your right arrow and it'll give you the last one. And you are done. No guessing, no left bounds, no right bounds.